The video you are watching now was processed in Blender 4.3 using video editing functions. When creating a new file and selecting video editing, we select General in the Rendering Plus tab and click Compositing. In this section, click Backdrop and create a chain of nodes. All nodes are connected to the yellow dot image. Start with Movie Clip, where we add a video file, then we combine with Blur, then with Denoise, then Glare, then with Sobel. From this node with the output yellow dot, we make a connection to two nodes, Viewer and Scale. In the node Viewer, we select Use Alpha. Also in the node Scale, we select Fit and connect to the final mode, Compose. Then go to Output Properties. And in the post-processing section, select only Compositing. I want to warn you that the 120-second video was processed by 72 hours in the Eevee rendered engine. And given that my computer has these parameters, Acer Nitro 5, Intel Core i5, and you can see the NVIDIA GeForce GTX 1650 video card plus, my RAM is 16 GB. Modeling the pendulum, creating the pendulum base. A nuvi sphere was used as the pendulum base. It was added randomly and edited to give it the desired shape. And our edge loop man was added in edit mode, which allows you to refine the geometry of the object. For further work, the UV sphere was converted to curves. Cut, which provided more flexible adjustment of the object's parameters. 53 working frames and 52 frames for rendering were created to animate the pendulum. This ensures smooth movement of the pendulum. Rotation was applied to the cylinder shen, which acted as a pendulum. Linear interpolation in Gen was set up to achieve natural movement. Slots were added, and a collision check was performed to prevent the pendulum from intersecting with other elements of the scene. Additional elements to improve the visual perception. Smooth shapes were added and scene elements were edited. Camera and object setup. Switch handling. The camera was activated and adjusted to adjust the framing of the scenes. View display composition guides and was used for precise centering. The camera position was determined so that all scene elements were aligned and decorated. Material creation and setup. Working with materials. Materials were created and edited for all scene elements. This is a change in color, texture, and reflectivity. The balloon was adjusted to material animation so that they indicate the movement of the pendulum. A black material talkie was created for some elements, which was intended for contrast and emphasis. Lighting setup. Using Eevee. The Eve engine was chosen for rendering, which provides high performance and high quality rendering. Directional lights were added to give shape and texture to the objects. Light intensity and refraction were adjusted to achieve realistic lighting. Rendering and saving the animation. Preparing for rendering. The animation was reset to 252 frames to ensure smooth movement. All scene elements were checked before final rendering. Saving the animation. The animation was saved in the specified document with the rendering path specified. Rendering was done in 3D, and the result was confirmed to match expectations. Adding soundtracks. Working with the video editor. The rendered element was added in the video editor Blender. The frame count was increased, and the element was duplicated to create a longer animation. Adding sound. To finish the project, a soundtrack was added, which is synchronized with the pendulum movement. The final animation was saved, taking into account the soundtrack. Conclusion. The project Pendulum Animation in Blender 4.3 provides the program's capabilities for creating complex animations using various tools and techniques. Each stage of the work, from modeling to rendering, was carefully worked out to achieve high-quality visualization and realism. This project can be used for more complex animations and experiments in Blender.